Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of basicity versus acidity. A few foundational things to think about and understand. First of which, all of this is based on the premise of the fact that water by itself is a very poor conductor of electricity because there's very little ionization going on. If we were to have the self-ionization of water, in other words, two water molecules come and collide, you would end up with this chemical equation, this resulting Kc. Well, the concentration of water, molar concentration, is fixed. So if I multiply that over here, I can call that Kc times that 55.6 molar squared another constant, and we'll just call it Kw. That's what everybody in the scientific world likes to call it. And at 25 degrees Celsius, both concentrations are 1 e to the negative 7, and as a result it gives you this Kw value. Okay? This is again only at 25 degrees Celsius. There are different Kw values for different temperatures. So now if we're looking at pure concentrations of the hydronium ion, or H+, whichever one you want to use, and if it's greater than the hydroxyl ion concentration, the solution is said to be acidic. And if they're equal, it's said to be neutral. And if, in this case, the hydronium is smaller than the hydroxyl, it's basic. We could also look at it in terms of pH. pH is the negative log of the hydrogen concentration. And if it's less than 7, it's acidic, equal to 7, it's neutral, and greater than 7, basic. You can also find pOH analogous to your pH formula. And remember, if there's no base to your log, that means it's base 10, so to get rid of it, your mathematical skills should be able to handle this. Oops, I should have divided first both. I guess my mathematical skills couldn't handle, and that yellow is kind of bright. Let's try in red. So if I divide both sides by the negative, then I take 10 raised to both sides, I have the other formula. You can memorize if you want to. Understanding is better. These two are the same, so they cancel each other out, leaving me the OH minus. Alright, and as a result, if you were to look at the relationship between pH and pOH, you add them together, they should equal 14. So if you know one and want the other one, just do 14 minus the one that you know to get the other. Okay? I think that's basically it. Make sure you check out the example videos associated with these. This is going to be leading us to the Ka calculations and neutralization titration type calculations. If you remember, neutralization is an acid plus a base gives you a salt plus water, usually. Okay, and we're going to be doing this in detail here, doing the different types of titration scenarios. So just check out the example videos for the calculations associated with KWs and pH basic calculations, and go from there. Practice, practice, practice. Thank you, and have a nice day.